Welcome to the DIY Honda Garage channel. The Honda Accord from 2012 to 2017, when encountering the diagnostic trouble code DTC P0365, indicates a problem with the CMP sensor B circuit, specifically a no-signal condition. The CMP sensor, or camshaft position sensor, monitors the position of the camshaft and sends this data to the powertrain control module, PCM, essential for engine timing and optimal performance. Every time the engine operates, this sensor ensures that the cylinders fire at the right time. In this case, the error code suggests that the PCM is not receiving a signal from CMP sensor B, disrupting this critical function. It's important to address this because it can lead to various performance issues, including difficulty starting and misfires. The troubleshooting process will guide you through verifying the DTC, checking the wiring, and ensuring proper component function to restore normal operation. In the sixth and final troubleshooting step, carefully check for continuity between the CMP sensor B connector and the PCM connector. Ensure that the ignition is off while performing this continuity check to maintain safety and accurate readings. You're looking for continuity between test point number 3, located at the CMP sensor B connector, and test point number 30 on the PCM connector B. Achieving continuity is a positive indicator that the TDC wiring is intact and that signals should ideally be communicated correctly. If continuity is confirmed, it may be advisable to update the PCM software if not up to date, or even consider replacing the PCM if you have access to a known good unit. Failing all these actions, repairing any detected opens in the TDC wire remains crucial to correctly diagnosing and rectifying the issue at hand. Finalizing the troubleshooting process with a comprehensive repair verification step is essential. Start by returning the ignition to the lock position, ensuring that all systems are deactivated before making any reconnections. After reconnecting all previously disconnected connectors, it's crucial to exit the SCS mode using the HDS. Switch the ignition to the on position and prepare for the last phase of repair verification. With the engine in on mode, reset the PCM to ensure the updated repairs take effect. Proceed to perform the PCM idle learn procedure, which recalibrates the PCM settings as necessary. Finally, check for pending or confirmed DTCs once again using the HDS. If the DTC P0365 reappears, it indicates further issues, while no codes suggest that the problem has been successfully rectified. Ongoing preventive maintenance for the Honda Accord can significantly reduce the risk of encountering DTC P0365 in the future. Start by regularly inspecting wiring connections associated with the CMP sensor B and ensuring that they are secure and free of corrosion. At the same time, routinely check the sensor connections, both at the sensor itself and the PCM, for any signs of wear or damage. An additional step involves updating the PCM software at scheduled intervals. Various improvements and fixes in software upgrades can greatly enhance system functionality and compatibility, preventing honed-in DTCs such as P0365 from becoming an issue. Employing these practices helps ensure the longevity of vehicle systems, optimizing overall engine performance. In conclusion, understanding the role of the CMP sensor B is paramount when tackling DTC P0365 for the Honda Accord. This sensor is integral to maintaining proper engine timing and performance. By following a structured troubleshooting approach, you can systematically identify the root causes of the problem, whether it lies in faulty wiring, the sensor itself, or complications within the PCM. Proper verification, as well as preventive maintenance, will be invaluable in preventing future occurrences of this code. By regularly monitoring and maintaining critical engine components, you ensure both the reliability and performance of your vehicle, making for a smoother and more efficient driving experience. The CMP Camshaft Position Sensor B is crucial for determining the camshaft's position in the Honda Accord's engine. It is typically positioned near the camshaft or at the top of the engine, where it can accurately monitor rotation. Its primary role is to send real-time position signals to the Powertrain Control Module, PCM, which then uses this information to ensure that engine timing is precisely coordinated. The sensor operates based on a voltage signal that should fluctuate according to its position. When the DTC P0365 is present, it indicates that the CPU is not receiving the necessary signals, which can lead to erratic engine behavior or even stalling. Understanding the wiring and connections that lead from the CMP sensor to the PCM is essential for effective troubleshooting. Several possible causes may lead to the DTC P0365 situation. Firstly, open wiring connections between the CMP sensor B and the PCM can disrupt signal transmission. This often involves inspecting the wiring harness for breaks or disconnections. A faulty CMP sensor itself may also be the culprit, as it may have degraded over time or failed suddenly. Additionally, shorted wiring can create a false signal condition, prompting the PCM to indicate a no-signal error. Problems within the PCM, while less common, can also trigger such errors, especially if the unit has not been updated recently. Lastly, loose terminals at either the CMP sensor or PCM can lead to intermittent connectivity issues, exacerbating the error condition. When the DTC P0365 is present, various symptoms typically arise as a result of the CMP sensor B circuit malfunction. One of the most common signs is an engine misfire, where the engine struggles to maintain a consistent rhythm. Often, owners will notice that starting the vehicle becomes difficult. It may crank longer than usual or fail to start altogether. Rough idling is another frequent complaint, where the engine exhibits shaking or vibrations when at rest. Additionally, reduced performance while driving can be experienced, as the engine might fail to respond promptly to acceleration demands. The check engine light, CEL, will illuminate on the dashboard, providing a warning that diagnosis and corrective actions are necessary. Recognizing these symptoms can facilitate timely interventions and prevent further complications. The first step in troubleshooting DTC P0365 requires initial problem verification. Begin by turning the ignition switch to the on position, which may also be accomplished by pressing the engine start-stop button. Once the ignition is activated, clear the DTC using the HDS, Honda Diagnostic System, which resets any stored trouble codes in the PCM. Following this, start the engine and monitor the status of the DTCs again via the HDS. This step is crucial. If DTC P0365 reappears immediately, it confirms a persistent issue. If the code does not return, there may have been an intermittent problem not currently affecting the system. Any findings from this step inform subsequent troubleshooting actions, emphasizing the importance of thorough DTC verification. In the second troubleshooting step, the focus shifts to assessing the integrity of the wiring connected to the CMP sensor B. Begin by turning the ignition switch to the lock position, ensuring that any electrical circuits are powered down. Next, safely disconnect the CMP sensor B from its 3P connector to isolate the component from the system. With this connector removed, turn the ignition back to the on position to prepare for testing. It is critical to measure the voltage between designated test points, as outlined in the diagnostic protocol. Specifically, check between CMP sensor B 3P connector number 1, which is typically the yellow-black wire, and a known good body ground. This step helps ascertain whether power is reaching the sensor, and checking for battery voltage here indicates proper delivery of electrical supply. A lack of voltage may suggest wiring or connector issues. Moving forward to the third step, the task is to measure voltage related to the TDC line to further pinpoint potential failure areas. With the CMP sensor B still disconnected, verify voltage at another set of test points. Specifically, measure the voltage between test point number 3 of the CMP sensor B connector and a body ground. Under these testing conditions, you should expect to see around 5.0 volts. This reading confirms that the sensor is receiving adequate reference voltage and that the TDC line is functioning properly. If this voltage checks out, it indicates that the wiring and sensor itself may be in good condition and points toward proceeding with further tests. If the voltage deviates significantly from 5.0 volts, it raises concerns about incorrect voltage levels, leading to troubleshooting the surrounding wires or the PCM. The fourth troubleshooting step centers around checking the battery voltage across two specific connections within the CMP sensor B harness. Ensure that you are measuring between test point number 1 and test point number 2 at the CMP sensor B 3P connector, while still in the on mode. Ideally, you should detect battery voltage here. If the meter shows appropriate voltage levels, it indicates that both circuits are intact and operating correctly. Should everything be in order, the next logical action would be to replace the CMP sensor B itself, as the problem may lie within the sensor rather than the wiring. Following the replacement, it's critical to perform a repair verification by retracing all previous steps to confirm that the issue has been resolved. Step 5 involves verifying the absence of shorts in the TDC wiring. Start by powering down the ignition switch to lock before performing any checks. Jump the SCS, Supplemental Control System line, using the HDS, enabling further diagnostic testing. Disconnect the PCM connector B 51P to isolate the PCM from the circuit. With both the CMP sensor B and PCM disconnected, you're ready to check continuity between specified test points. Specifically, verify continuity from the PCM connector B number 30, LT green, to body ground. Confirming continuity here is vital. It ensures that the TDC wire is intact without any shorts. If continuity exists, the issue points to a short in the wiring. If there is no continuity, the wire may be intact but requires further evaluation. Please like and subscribe to the channel. See you next time.